Good day, viewers. You are welcome to Soluble Tutors. Based on the yearning of people and the request, I have received a lot of messages from the comment section. How can you draw graph in your physics practical, most especially for WAEC? WAEC is expecting majorly 4 categories. The first category is table. The second category is the graph. And the third category, precaution. The fourth category is the general questions. But for all these categories, there are 13 steps in which WAEC is expecting you to give a lot of analysis. And the mark for your practical physics, which is 25 per question, 25 marks, will be splitted in the 13 steps. I mean, there are 4 categories, but there are 13 steps. Okay, let me name the steps before I start dissecting them one after the other. Now, the first step is the table. The second step, which is under the graph, is drawing your axis. How can you draw your axis? Okay. The third step is labeling your axis. The fourth step is giving your graphs a heading, or we call it title. Okay. The fifth step is choosing a scale for your graph, which is the most important one, and that is what you people are asking for, choosing a scale for your graph. The sixth is starting both axes from the origin. Why do you have to do that? Okay. The seventh step is plotting the graph. Okay. The eighth step is drawing the graph. The ninth step is calculating your slope. The 10th step is taking your intercept. The 11th step is testing of accuracy. 12th step is precautions. And the 13th step is general questions. The first one is the table. Look at this table, for example. Here we have table A and we have table B. On the table A, the first column is a reading that has been taken using meter rule. You can see that we have L in centimeters and we have I in amperes. That's the second column. And the third column, we have divided our L, that is, we have found the reciprocal of the L, that is 1 over L, which is L raised to the power of -1, and centimeter raised to the power -1. That's the unit. Now, there are many things wrong there. Number 1, look at the first column, which is the L in centimeter. You will see that we have 80.0, 70.0, 60.0, 50.0, 40.0. Now, let this be in 2 decimal places, not 1 decimal. Look at the correct fashion down there, which is the table B. You will see that L in centimeter, it has 80.00, 70.00, 60.00, and so forth. So let's go to the second column now. We see that current in ampere. Okay, looking at it, you will see that we have 0.22, 0.26, 0.3, 0.33, and 0.4. Look at that 0.3 and 0.4. You see that they are in 1 decimal place and the others are in 2 decimal places. This is very wrong. They must all be in the same decimal places. Most of the time, 2 decimal places, if they are the readings you took by yourself. There are 2 decimal places. Okay, let's look at the third column now, where we have the reciprocal of our L, which is the length. Okay, look at it. Whenever you divide any value under practical physics, let it always be in 3 significant figures. It's a rule that you have to follow. Let it be in 3 significant figures. Look at that. You see that it's in 3 significant figures. Look at the first one, 0.0125. That 125 is the 3 significant figures. But going down, you will see 0.0143, 0.0167, 0.02, and 0.025. That's 0.02, that's 1 significant figure, unlike the other that are 3. And also 0.025, that's 2 significant figures. That is wrong. Look at the correct fashion down in the table B. We have 0.0125 and the rest. They are all in 3 significant figures. That is the correct way to write your table. So that's it about the table. Please always make it neat. Try not to shade and make it very, very neat. You can write in pencil first before you trace with your biro. So the second step is drawing your axis. There are many ways in which you can draw your axis depending on the factor. The first factor, when all the horizontal and vertical values are positive, then position your axis as shown in the diagram. Okay, the diagram you will see that in the graph, the vertical line is on the far left and the horizontal line is below. That's when we have both vertical and horizontal being positive. Okay, when the vertical and horizontal both are when the vertical and horizontal have both positive and negative, okay, the drawing of your graph will be something like a cross as shown to you on the screen as you see it. So I believe this shouldn't be any problem, because the value of your table will determine how your graph will be in that manner. The third step is labeling your axis. When you are to label your axis, the vertical axis should be labeled accordingly and the horizontal axis should also be labeled accordingly. In this example, the vertical axis used in this video now is T, which is the period. You have squared the period already, and that's second square. That's the example used. Okay, and the vertical is the L, which is in centimeter. Okay, your experiment can be anything. This is just an example. This is just an example. So that's how to label. You must remember to label. That's step 3. Okay, now step 4. You must now giving your graph a heading. You must give your graph a heading. You must not forget, because there is a mark for that also. So look at it as it is shown in the screen. That's an example of an heading. A graph of T squared in seconds against L in centimeter. That's the example used there. So you have to write that. Labeling. Now let's go to the next step. The next step, which is step 5, choosing a scale for your graph. This is the most important one, and this is what you people are asking for. This is the most important one. Okay, scaling your graph. So you have to pay a lot of attention here, please. There is a method, very simple method I always use in scaling my graph. You have to take your scale properly. So let's get there. Before you plot your graph, there are some things that you have to do. The first thing is scaling. How do you get the scale of your graph? Let's take this as an example. If the question says this should be plotted on the vertical, just for example, and this should be plotted on the horizontal, what you have to do to scale is this. I have a golden method. The first thing you have to do is that you have to make sure that the highest value, your highest value, is divisible by 5. Please. Your highest value, I come again, must be divisible by 5. That is, the highest value must be divisible by what? By 5. Look at this. This cannot be divisible by 5 and give us, so you look at the first value here. Make sure the value is divisible by 5. And our graph must take, I love to take 2/3 of the entire graph. Our drawings must take 2/3. So this will cater for it also. So I would like to go, this one is 0.02. Okay, I would like to go for the nearest value that is divisible by 5, which is 0.05. See now? So I can easily divide this by 5. Once I divide this by 5, this will give me 0.01. So it means that's my scale for the horizontal. To take my scale for the vertical, what is the nearest highest value that is divisible by 5 in this scenario? That will be 0.50. 50 divided by 5, that will be 0.1 also. This is 0.1. So it means this is what I'll be taking for my vertical scale. This is the one for horizontal scale. So let's now get the graph and see how we can plot this. So after scaling the graph, the 7th step is plotting of the graph. that is allocating values to the verticals and also to the horizontal. So let's check it out. Now, using our table as an example, as you see it, we will plot this as the vertical and this as the horizontal. So if you have to do that on the graph, what we have to do is that, the highest value here is 0.250. And mind you, we have taken 0.01 for the horizontal. If you take our 0.01 here, 0.02, 0.03, and you see the highest there, so it will be small. So we cannot take 0.01 for 2 centimeter again. Let's go for 0.01 for 4 centimeter, 0.02, 0.03. It has taken the larger part of the graph. So if you go here also, instead of us taking 0.01, okay, which is for the vertical, 0.01, instead of taking it for 2 centimeter, because 0.01, if you take it up to 0.04, it will not take a larger percentage. So we now go for 0.01 as 4 centimeter, 0.02, 0.03, 0.04. It has taken a larger percentage of that. So another important thing for you to note when you are to plot is to know the value of each line. To know the value of each line. How will you know the value of each line? If you are using 0.01 here, it means you take 0.01, you divide by 10. Because between here and here, we have 10 lines. So it means you will divide by 10. But when you are taking 0.01 for 4 centimeter, you divide by 20 because we have 20 lines. So the value, any value it gives to you, will help you to navigate irrespective of the point. It will help you to navigate irrespective of the point. For example, this is 0.0125. Okay, just go to, in the horizontal, go to 0.01. Okay, it remains 25 that you have to put on top. That is, it means 0.0025. So you now look for the equivalent of each line for you to be able to know what we add to this, to know where it's going to be. Please put that in mind. The 8th step is drawing the graph. After you have plotted the graph, you have to draw the graph. Now, this is an example, because another thing is for you to draw your lines of best fit. You draw your lines of best fit. So this is an example of how to draw a line of best fit. This one is outside, this one is outside. Okay, so drawing the lines of best fit, you make sure your line that you are drawing touches like 2 or 3 of them, and you make sure that everything that is not on the line is not far apart to the left and to the right. You try to manage them. So the next step is calculating your slope. Now when you are drawing your slope, make sure your triangle is as big as possible, please. Very, very big. Let it be big. I know you are good at drawing slope, but let it be big, not just small one like this. So your slope here in this scenario will be I2, minus I1, because this is it, and divided by L reciprocal 2 minus L reciprocal 1, because this is also it. Okay, the 10th step is taking your intercept. Most of the time, some graph might pass through the origin and the intercept will be 0. But some other times, they might ask for the intercept at y-axis. So the 11th step is test of accuracy. That is, you might be given a formula whereby you have to insert your slope and get other values. The examiner always uses this to check your accuracy. So it's better to do it properly. Let's get there and see some examples. The test of accuracy can be in this form. You can see this is a formula given to you. You have to insert your slope. The S is the slope. You are being told to get your G. Okay, putting the slope, that will be 4 pi square times anything you get in the slope. You can have a lot of formulas like that. The 12th step is precaution. You will be asked to give at least 2 precautions depending on your question. So you have to give a proper precaution, and when you are mentioning the precautions, there are some things you have to mention. You must say, I ensure that. You should always start your precaution with that. The best precaution we always use for things that deals with measurement is to say, I ensured that I avoided error due to parallax while taking my readings. That one is common among things that deals with measurement. So you have to check, you have to know at least 3 or 4 precautions. For example, in electricity, In mechanics, in optics, that is light, just try to know 3 or 4 precautions so that when you get to the exam hall, you'll be able to state it. The 13 steps about general questions. This one you have to go and do a lot of work and research. Go and check past questions. Make sure you studied the topic very, very well and look at the formulas that are applicable. I will also make a videos on formulas for physics in O levels. I'll make a video on it. So if you have an interest, you can put it down in the comment section below. So this is an example of graph showing line of best fit. You can see that in this graph, we have 1, 2, 3, 4, 5. We have 5 points. And knowing fully well, it is only the first and the second that the line goes through. But during this line, make sure that every other point are very close to it. So that's line of best fit. And when the slope we are taking, you can see as big as the triangle is. The triangle is very, very big before you can take the slope, not the small triangle. Okay. And as you see, it is well labeled. Okay. After you have the good labelings here, okay, it is having a good heading also. A graph of, because they are taking this, okay, v in centimeter per second, okay, against t in seconds, and the scale is 2 centimeter to 10 units. You can see that. You can use the one I used in the example earlier. I use 4 centimeter. It will be 4. Might not divide. You might just call it 4 centimeter to any unit you are taking. It's not compulsory. It is 2 centimeter. So this one is 2 centimeter to 10 units, and this one is 6 centimeter to what? To 1 unit. Just remember, as I've told you, make sure the highest value is divisible by 5. That's the first thing, before you now start to divide based on the lines. Thank you. So thank you and God bless you for watching this channel. Okay, if you are new to this channel, please subscribe, press the like button, share with people so that a lot of people can benefit from this. Thank you and God bless you.